Okay, so our measures of central tendencies is all these three words start with an M, right? Kristen, can you maybe, do you remember one of these words that starts with an M? Or maybe could you give us all three if you know what they are?
So is it the mean and
Mm-hmm.
the mode and the median?
Nice. The mean, the mode, and the median. Okay. The nice thing about these words is they easy to remember, mean, mode, and median, and also easy to understand. So mean is simply just another way of saying the average. Okay. And we can work out an average by adding everything up and dividing it by the number of terms. The mode is simply the number that occurs the most. Occurs the most. Okay. I also like to think of it like this, especially when we do group data. Mode will be the one with the highest frequency. The highest frequency means that it appears frequently, in fact, the most frequent. Okay. And then median, another word for median you can think of is middle. Okay. Here we are looking for the middle term. Now, very important that your data is always arranged in ascending order or descending order. So it either needs to be arranged from lowest to highest or from highest to lowest. And that's the way you'll find your middle term. Okay, so hopefully you guys have no problem with this. This is grade 8, 9, and well, grade 8 and 9 concepts. Let's move on to measures of spread. Okay, I can think of a bunch of things here. The first thing that's coming to mind is the range. Okay, when you talk about how far out the data is spread, you immediately think about range. Like, what is the highest value of the data? What is the lowest value of the data? Because range is simply the highest value minus the lowest value. So I would say it's difference between the highest and the lowest value. Um, Other things that we use to, I guess, determine the spread of the data are the quartiles. When we break our data up into quarters, now there's exactly three quartiles that we are interested in. That's the lower quartile, quartile 1. That's the median, quartile 2. And it's the upper quartile, quartile 3. Okay, so we just refer to it as Q1, Q2, and Q3. And like I mentioned, this middle one is actually the median. Quartile 2 is actually the median. Speaking of quartiles, you also get something that's called interquartile range. Let's write that down. When they ask you for the interquartile range, what are they asking you to calculate? Anna?
Is it not Q3 minus Q1?
Yes, correct. It's Q3 minus Q1. So it's your upper quartile minus your lower quartile. We also then have percentiles. Percentiles. These are very easy to like calculate. You simply take the percentage, whatever they like. If they ask you to work out the 25th percentile, you just take that 25 over 100, you multiply it by the number of terms, and that will give you the position of the percentile. So a quick way to demonstrate this would be if I asked you to find the 25th percentile, let me just write that again, 25th percentile of, okay, let's make up some random data. So 2, 3, 4, 4, 5, 6, 6, 6, Illuminati, 7, 8, 9, 13. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, cool. So here what you do is, since there are 12 terms, what we can now do to work out the 25th percentile is simply take 25 over 100 multiplied by 12. Okay, and that should give us an answer of 3. Okay, 25% of 12 is 3. So therefore, your 25th percentile will be the third term. And if you count, the third term is this one over here. I'll just label it as term number 3. Okay, and there you go. That's basically a simple example of using the percentiles. Standard deviation. Standard. This also speaks of the spread of the data. Deviation means to deviate from the mean. Deviation. Okay. And standard deviation is represented with a sigma, the Greek sigma letter. That will look something like this in your calculator. Something like that. I think I will use the example to demonstrate how the standard deviation works. Or let me do a quick example. Let's say you all were to write a test, a math test, for example, and the mean for this math test, meaning the average score is 65%. Okay, so everybody got about, well, not everybody, but everyone together, if you worked out the average, it was 65%. And then by some calculation, using the data, we also then work out the standard deviation to be 15%. Okay, what that then means is that within one standard deviation of the mean, so let me just show what is one standard deviation. One standard deviation to the right would be if we add 15 degrees, which takes us up to 80%. And one standard deviation to the left would be if we minus 15%, and that takes us to 50%. Okay, so one standard deviation within the mean would be between 50% and 80%. Okay, and statisticians shows that 67% of the sample space will lie within this percentages of the mean. So this mark here, this 50% and the 80%, 67% of the people that wrote the test would have scored between 50 and 80%. Okay, then the entire group, or at least most of the people in the entire group, would have stood between two standard deviations. So if I were to add and subtract 15 degrees one more time, we'll end up with 95%. And what is this? 35%. Here, approximately 95% of people should lie within these two standard deviations of the mean. Now, if there's anyone else that stands outside two standard deviations of the mean, like what I'm trying to say is, if there's anyone that scores, in this case, less than 35% or more than 95%, they are then considered what we call outliers. Okay, an outlier is too far away from the mean. Okay, and they kind of pull the data towards one side. They would skew the data to the left or to the right, depending on where they, where the outlier is. So if there's someone getting lower than 35%, they will be bringing that average down. And if there's someone getting higher than 95%, they'd be bringing the average up again. Okay, so an outlier would be anything further than 2 standard deviations away from the mean. Okay, so that's the definition here of standard deviation, or not the definition, but that was an example of that. And then just as a last bullet point here for measures of spread, I'd like you to include outlier. Okay, identifying outliers is another way of, showing how far the data could be or is spread out. All right. Now, that is all the theory or the things that we need to know before we do the practice. The practice itself, the graphs or the methods in which we would see or do the statistics will be either a box and whisker diagram, maybe perhaps an ogive. Some of you might know it rather as a cumulative frequency graph. And last but not least, the line of least squares regression. And I trust that all of you have done this already. Tamlin, do you perhaps know or remember the equation to the line of least squares regression? It starts with y is equal to. And it's very similar to a straight line.
Is it bx plus a or something like that?
Yes, correct. I just like to write it the other way. I would say a plus bx, because this is how you normally see it in the calculator. But bx plus a is the exact same thing. And I think the reason why you might have, or the reason why you were taught it perhaps in this way, bx plus a, is because they were trying to show that it's actually similar to the equation of a straight line, where b is the gradient and a is the y-intercept. Okay, so this is possibly the most important thing that you need to know for grade 12, the line of least squares regression, but also the ogive and also the box and whisker. That's just as important. So we might not be able to go through all of these methods and graphs, but if I do skip one, I will make a video on that separately some other time. Okay, let's move over now to the practice.